Let's go. You guys are starting to mark your diagram. It's lowercase angle A congruent to lowercase angle B. One job. And look, try to identify where the prove angles are right now. All right, look at the angles we're proving congruent. Don't mark them because it's not true. All right, but make sure you know where they are in your diagram, the angles we're trying to prove congruent. Okay, make sure you take a look in your diagram. All right, ready to help me out? Yesterday, I mentioned we are at the point in this unit where you could do a proof multiple ways. This is one of them. We could do this using subtraction. Anybody see subtraction? Ooh, maybe, yes, no? What are you going to subtract A and B from? What could if I were to do it using subtraction, which I could subtract A and B from your what type of angles here? Straight angles. Say the straight angles are congruent and subtract. We could do it that way. All right, but I want to use some of these new facts. All right, I'm going to turn it over to you guys right now. Angle A and angle ADC, one of the prove angles here. What do I know about them? Don't yell anything out. I'm going to call on somebody. Lowercase a and angle ADC. What do I know about those two angles if this is a straight line? Open it up to you guys at this point in the unit. 6. Why? They're supplementary. Love the talk. All right, love the vocabulary. Over here now, what do I know about lowercase b and angle BFC? What are my prove angles? What do I know about these two angles? Hi. I'll be with you in a second. Thanks for making an appearance. 23, what do I know about those two angles? They are also supplementary, everyone. Yes, correct? Okay, so didn't we have something yesterday we talked about, one of those 4 new facts, that if two angles that are supplements of the same congruent angles, these angles must be congruent. So that's what we're going to use here. Supplements of congruent angles are congruent. But, whoa, this isn't going to be a 2-step proof. Somebody tell me why it's not a 2-step proof. I know at the end of the proof I'm going to use supplements of congruent angles are congruent. But before I'm allowed to say that, what do I need to tell you? They are what? I need to, oh boy. What do I still need to tell you? And I discussed this with a couple of your classmates already. Logan, what do I still need to tell you? What are they? What are the supplementary angles? All right, so start writing in number 2 now. Where are the supplementary angles? Because I'm going to ask somebody that in a second. Name the supplementary angles. If you want to sit here, that's fine too. It's up to you, wherever you're comfortable. Yep. All right, here we go. Name a pair. Name a pair of supplementary angles. This angle and this angle are supplementary. Don't tell me the straight line. Name the 2 supplementary angles. 24, name a pair. Great job, 24. 6, name a pair. Angle. Angle lowercase a and angle ADC are supplementary. And there's another pair up there that are supplementary that we discussed, and they would be 3. What's the other pair? Yep. Nice job. Why? No, 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 no. There's a specific reason I want here. And I want it specific because we use it. No? Linear pairs are supplementary. I will let you know 99% of the time this year, you tell me angles are supplementary. This is the reason we're going to write down. Linear pairs are supplementary. Now that you told me they exist, all right, now that you told me they exist, again, recapping, what do I know about angles A and B? So anything supplementary to them also has to be congruent. In this case, angle ADC, congruent to angle BFC. And this is one of our new facts from yesterday, supplements of, what type of, they're supplements of, not the same, congruent angles are congruent. And I know, yes, again, I'll repeat what we said at the beginning. If you wanted subtraction on here, you could. Anything you want to ask? All right, let's keep grinding. Is everyone all right? It's an if-then type proof. You know where the givens are located. You know what I'm asking you to prove. All right, I need your help. I need to get 1 and 3 congruent. Please don't start adding in things that aren't there. I don't want to hear about parallel lines if you were thinking about that. We've never discussed that. Don't throw it in. Okay, you're not ready for that. Don't throw it in. I also want you to notice, do you see that I only put numbered certain angles up there? Those are the ones I want you to focus on. Because I'll get from time to time, hey, Mr. Carlino, they didn't put a letter here. Can I put my own? If you're putting your own there, you're focusing on the wrong stuff. Okay, if you're adding in your own letters. I only want you to focus on 1, 2, and 3. That's why I put them there. Not any of the other angles. All right, so we know 2 and 3 are congruent, but you guys got to get me to 1 and 3. Is there anything on that diagram that you see that we've talked about in Unit 1? There's a hint that we talked about in Unit 1. Anything at all, Maya? You see verts there. There's a pair of vertical angles. Where are they? No, I don't care about those, though, right? I only care about what the one pair, which is what? 2 and 1. Everyone see 2 and 1? And also, I want to point this out. A lot of people just write it and they just skip over it because they think it doesn't matter. It matters. There's a reason why I gave you they were lines and they intersect, because vertical angles are only formed by what type of lines? Intersecting lines. So don't overlook that fact that I gave you that they intersected, because I want you to say ding, 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 vertical, vertical. What do we know about vertical angles? They are congruent. So step 2 is going to say angle 1 and 2 are congruent. And it's not definition of vertical angles. It is the final fact that I'm giving you for this unit, which is vertical angles are congruent. Where do I go from here then? Because I still need to get 1 and 3 congruent. Look at the work you just did. I just didn't put 1 congruent to 2 just to maybe get some partial credit. I put 1 congruent to 2 to use the darn thing. All right, look at your givens. Look at what you just wrote down. Is there anything you can conclude from any of those? You wrote down 3 is congruent to 2, and now you just wrote down 1's congruent to 2. We got a little something here. 3 again, on fire today. Anything? 3? Okay, ready? It's just not I don't know, and I'm listening to my partner, so I'm going to say whatever they say. 3 is congruent to 2. 1 is congruent to 2. So can I take 1 and substitute it in for what? What's it congruent to? So can I just substitute 1 in down here for 2? And what do I get out of that? Okay. And what did I just do there? Do you see it now, yes or no? Does everyone else see it? And also, if you don't I have duplicates here? Didn't we talk last week? Anytime you see duplicate, angles or segments, it's probably substitution. So 3 congruent to 1. Substitution. Okay? Do not overlook this given. They want, if you are finding that they are giving you lines intersect, or look back at the last proof we did. They gave me straight lines intersecting. It's either vertical angles or linear pairs. Going to be involved somehow. All right? All right, I'm going to break this to you now. We're done doing the average level proofs. This is honors level now. Okay, this is honors level. This is part of your homework. It's not on page 32. It's on the next page, 31. It's question number 2. It's a homework problem we're going to get done together right now. Okay? But I'm going to let you know it's honors level here. Gloves are off. Okay, ready to go with me? I gave you x was congruent to y, and you need to get me m is congruent to n. All right, I don't know if anybody are thinking this, but let's squash this idea. M and n are not vertical. Okay, this is not a 2-step proof. All right, why would I give you x and y then if it was just going to be they're vertical and I'm done? All right, they're not formed by intersecting lines. I gave you 2 lines intersect, right? All right, let's focus on those 2 lines that intersect. You see me using them a lot too. You are more than welcome to use markers, highlighters, or colored pencils on any diagram of your proof. If that helps you see things better, feel free. Okay, that's totally your call. Okay, I'm fine with it, and you can do it on any test, quiz, or the Regents exam. All right, now that I highlighted those lines that intersect, I don't know if that helps anybody, how I'm going to use x and y there to get to m and n. I'll give you a couple more seconds here before I ask somebody, because I'm not going to give it to you. Now that I know those angles intersect, those lines, Do I see anything starting the form that I could use with x and y to get to m and n? Anybody see anything? Come on, don't give it away. Just tell me what your next step thought is right now. I don't want you to give away the whole proof, though.
The next step, yeah, I only got as far as the next step.
Okay, what is it?
Angle DEA is vertical to angle BEC.
So if they're vertical, because I don't need to know, I don't need to write down they're vertical. I can automatically say they're what if they're vertical. Okay, so here you go, guys. Ready? Let me mark that on my diagram. What he just said. Not like that though. Here's what he just said. DEA, this angle right here, is congruent to BEC, this angle, because they're vertical. Yeah. Now, some of you that may have been stuck, am I getting you on board where to go from here now? What I can do with the vertical angles in x and y now, maybe to get to m and n. Angle DEA, congruent to BEC. Vertical angles are congruent. All right, where am I going here? Where's this leading me to get to m and n? We've discussed this. What can I do with these angles to get to m and n? One, any ideas? I can subtract. Hold on. How many quantities do I need? How many did you write down already? 2 are written down, so yep, you can subtract. This is a subtraction problem, believe it or not. Somebody let me know what angles we're subtracting to get to m and n. 9, what angles are we subtracting? Angle. Yep, DEA, AED, same angle minus angle. DEC, that's the straight angle. Aren't I subtracting the vertical angles and angle x and y? Right? So AED, which is my vertical angle minus what? Minus angle x is the same if you do what other two angles subtracted? Angle BEC, and I'm going to subtract angle y. And after every subtraction comes a substitution to finish it off. I'm going to substitute in angle M congruent to angle N. Hey, that's where we are. That's where we are, guys. An angle fact along with postulates from last week. That's what our proofs are right now. That's where they are. That's where they'll stay. Okay? Highly unlikely now you're going to see two-step proofs. All right? Questions at all? All right, so from now until the end of tomorrow's class, we're just grinding out proofs. Okay? Grinding out proofs. I believe you guys have pages 31 to 34 tonight. All right, let's get going. I'll if you want me to look over a proof, I certainly will. If you want me to get you kick-started, I certainly will.